Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to take a look at finding the least common denominator of rational expressions. So let's go ahead and get started. So what we're going to do here is that when we're looking for the least common denominator, the problem that we're facing is that the denominators are different for two rational expressions. And so when this is happening, you cannot add, subtract, multiply, or divide because the denominators are different. And again, this is an idea that carries over from fractions. So all we're going to do in this video is find the least common denominator, and then we will expand on this in other videos when we have to add rational expressions with different denominators, multiply, subtract, divide, etc. So let's just say that I have the following two rational expressions. Here. So I have, let's see here, 2 over x squared minus x minus 12. And then my second one, we'll put a comma, that's a big comma. We'll put a little comma to separate them. We'll have 1 over x squared minus 16. So these are my two rational expressions. And I need to find the least common denominator that these two have in common here. And so the process of this is very simple. You factor the denominators for each rational expression, and then you bring down all the different factors that you do, and you make that the new denominator. Now that sounds kind of abstract right now, so I'm going to demonstrate that. So first, I'm going to deal with this guy right here because the second one is very easy if you're a little bit more familiar with the factoring. So x squared minus x minus 12. And so again, following the AC method, we need something when I multiply it comes out to negative 12. And when I add it up, it comes out to negative 1. So using our senses here, I can see that if I do negative 4 and positive 3, I will meet the criteria. Because negative 4 times positive 3 will be negative 12. And negative 4 plus 3 will be negative 1. So I get the following. I will have x squared minus 4x plus 3x minus 12. And then when I group, I will get like this, 3x minus 4, like so. And then over here, when I group these, I put the x on the outside, and then I have x minus 4. So basically what's happening is that the values that we have for this first one are going to be as follows. Let me see here. It'll be x plus 3, x minus 4. That's what we got for the first one. All right, now for the second one, this will be a lot easier. If you're familiar with a difference of squares here, or factoring by squares or whatever, x squared minus 16, and again, I'm going to solve this real quick because we should hopefully be familiar with this. It's just simply x plus 4, x minus 4. And again, because what will happen is that the positive 4x and the negative 4x cancel out, and then you have 4 times negative 4 will make negative 16. That's kind of how you get that. And so for this, and then for the second one, we get as follows. We get the x minus 4. That's what they have in common, and then we have the x plus 4. That's what we have here. So now what we do is as follows. We bring down all of these different factors, especially ones that are not in common. So for example, we bring down the x plus 3, like so. We bring down only one set of the x minus 4. We don't need both of them, so we bring down one. Let me close that out. X minus 4. And then we bring down this x plus 4 over here that's by itself. This right here, this is the LCD. This is the least common denominator for our two rational expressions right here. So if I redraw this, I will get the following. I will get 2 over x minus 4 and x plus 3. This is the original. I'm going to explain why I'm doing that in a second. So x plus 3, x minus 4, and then for the second one, I will have 1 over x plus 4. Oh, let me scoot that over a little bit. It's a little bit too squished. So I have 1 over, let's see here, x plus 4 x minus 4, like so. Now, in each of these, we're not completely done. And so what we have to do now is that you know that we have to finish it. Now, I'm trying to make this clear, but essentially what happens is that the one factor that is missing is added to the numerator. So in our first example, we have x minus 4, x plus 3. Okay, we need the last factor right here of x plus 4. All right, now this is new because remember, this was already the original polynomial in the bottom. But see, now that we have the x plus 4 in the denominator, you have to add it to the numerator as well. Otherwise, you start to change the value. So that goes up top. Now over here, we have x plus 4 and x minus 4. So what's new over here is the x plus 3, because this is the original polynomial right here. So we haven't changed anything here. But when we add the x plus 3, like so, we must add it to the top as well. Just like that. And so now we're just about completed. Now the only thing we're going to do now, the last step in this video, because there's much more that could be done here, is we simplify the numerator. We're not going to simplify the denominator in this particular video. So the final answer, if you will, to try to make this as clean as possible is going to be 2x plus 4 over x minus 4, x plus 3, x plus 4. That's for our left-hand side, and then over here for the second rational expression is going to now be x plus 3 because the 1 just disappears, so you're multiplying by 1, and you have the same, of course, denominator, x minus 4, x plus 3, and oh, I'm getting a little squished here, x plus 4, like so. And essentially, in this video, we're done. Of course, there's much more that could be done with this. Like, for example, if we were going to add these together, we would finish it off and we get like 3x plus 7, I believe. Something like that. But for this video, all we did was we focused on determining how to get the least common denominator for rational expression with different denominators. So all that we did was as follows. You have your two terms at the beginning, the two rational expressions, like so. And all you want to do is you first want to factor them using whatever method you prefer. I prefer the grouping or the AC method, if you will. And I'd use the difference of squares here. And then once you do that, this becomes the new denominator temporarily. But you're not quite done. You have to bring out all the different factors that you find, and that becomes the new denominator. So in this example, I brought down the x plus 3 because it was alone, but I only brought down one x minus 4 because there are two of them. You only have to bring down one. And of course the x plus 4 as shown here. Once you have done that, you now can remake your rational expression, but you must also add the new, whatever term is new for that particular expression. You must add it in the denominator and also add it in the numerator, so that you have the same change in both numbers there. Otherwise, you'll have a different value. And you do that, of course, also for the other rational expression. And then in this video, we simplify the numerator to conclude the video. Oh, I made a mistake right here. This is not. This is supposed to be 8. I'm sorry. This is not 4. 2 times 4 is 8. Excuse me. And so our final answer was 2x plus 8 over x minus 4, x plus 3, x plus 4. All right, and then off over here to the side right here, we also have our other value here because 1 times x is x, 1 times 3 is 3. I should have closed off that parentheses, getting sloppy here. And we have our value there. So if we were to add or subtract or multiply these things, we would essentially be ready. Now, primarily you need the same denominator, especially for addition and subtraction. Not so much for multiplication. I misspoke there. But you can see this is how the process works. So I hope that this made sense for you and that you were able to appreciate what we were trying to do, and that you were able to take this information and apply it as you deal with other problems and challenges in algebra or math in general. So my name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.